Welcome to this week's episode of Weather Extra. I'm First Alert Meteorologist Jillian Johnson. While things were quiet across the tropics this past week, forecasters are still predicting a hyperactive season. So far this year, we've already had 3 named storms, and the National Hurricane Center is predicting as many as 25 from now through the end of November. The first system of the season was the Tropical Storm Alberto, which developed on June 19th. Alberto was a short-lived tropical cyclone that impacted parts of Mexico and Texas. The second and strongest storm of the season so far was Hurricane Beryl. Beryl broke numerous records, but one of the most notable records was that this storm became the earliest Category 5 Atlantic hurricane on record, with maximum winds of 165 miles per hour. Beryl was a deadly and destructive storm that impacted parts of the Caribbean, the Yucatan Peninsula, and the Gulf Coast, including right here in the Lone Star State, impacting southeast Texas the hardest. More than 50 people lost their lives due to this powerful storm. Tropical Storm Chris formed shortly after Beryl, but Chris was a weak and short-lived tropical cyclone that brought heavy rain and flooding to parts of Mexico earlier this month. While things may be quiet for now in the tropics, again, forecasters are still predicting an abnormally active season, which is why officials are warning residents to remain prepared this hurricane season. CBS's Christian Benavides reports on what the National Hurricane Center says people impacted should look for in the forecast of a storm.
Memories of Hurricane Ian still haunt Holly and Skip Messenger. They rode out the storm with their 2 granddaughters. By the time they realized Fort Myers would take a direct hit, it was too late to safely get out.
We thought, where do we go?
This cell phone video is from their 17th floor condo, where they hunkered down in the bathroom and felt the building swaying.
It was awful. It started in the morning and it never let up.
2 years ago, Ian made a last-minute turn away from the expected landfall in the Tampa Bay area, barreling into southwestern Florida as a Category 4 hurricane.
You have to pay close attention. Shifts can happen.
Patrick Fuller is the Emergency Management Director for Charlotte County, which saw Hurricane Charlie make a last-minute shift in 2004.
The National Hurricane Center gets better and better every year at forecasting storms, but it's not an exact science yet.
Forecasters say it's important for the public to understand that storms are now rapidly intensifying, meaning that a Category 1 could quickly turn into a major hurricane.
The National Hurricane Center urges everyone to listen to hurricane and storm surge warnings. Jamie Rome is the deputy director.
And they're highly effective, and they're the most important thing we issue, more important than models, because they're actionable.
If they're up, it means the risk is great enough that you need to take some action to protect your life, protect your property, and listen to those local officials.
In August, the National Hurricane Center will begin testing a new cone graphic, providing more information about risks inland. Forecasters already predict as many as 25 named storms this season, saying now is the time to prepare. Christian Benavides, CBS News, Miami.
The other major story so far this summer has been the record-breaking heat across the globe. According to the EU's Copernicus Climate Change Service, June was the 13th consecutive month to break a global heat record. Now, scientists say heat waves are becoming the new normal. Here in the U.S., this June was the second warmest in NOAA's 130-year record. According to the National Centers for Environmental Information, last month ranked in the top 10 warmest Junes on record for 20 states. And we've seen more of the same in July as well, as more than half of the U.S., some 175 million people, faced extreme heat on the 4th of July. And more than 100 cities from Maine to California have experienced their hottest summers on record this year, Las Vegas being one of those cities, as they have been shattering all kinds of hot weather records. For 7 days straight, the city experienced temperatures at or above 115 degrees Fahrenheit. And according to the National Weather Service, Vegas saw its hottest temperature ever back on July 7th at 120 degrees. At least 37 people have died just in the month of July from the excessive heat. And there's also been a heat wave across southern Europe that's caused some tourist cities, or sites rather, to shut down. Some cities were expected to feel 110-degree temperatures this past week into the weekend. Lee Canary has a story from London.
Europe's southern cities are under a bubble of extreme heat in peak tourist season. The ancient Acropolis, one of Greece's most famous attractions, closed by Greek authorities.
A little upset that we can't go up and see the Acropolis on the only day we're here. So, yeah, not real happy right now.
I understand for safety maybe why they did it. People push themselves more than they should.
Temperatures in the south are predicted to pass 109 degrees as a heat wave from Africa blows across Europe. Wildfires have sparked in several countries. In Macedonia, the government declared a month-long state of crisis. Italy has placed 13 cities under its most severe heat warning. An American in Rome cooled down the Italian way.
It's so hot, but we can help with the gelato.
Why not swim in the sea? Well, the Adriatic is measuring record-high water temperatures of nearly 86 degrees.
It's hot too, but it's still refreshing.
Meteorologists have warned the hot air is set to bake the wider region until Sunday. After that, all eyes are on Paris, where 15 million people are expected to visit during the Olympics. Some predict it could be the hottest games on record, but so far the City of Love has been spared the scorching heat. Lee Canary, CBS News, London.
And with millions under heat alerts throughout this summer, households and businesses might want to think about how extreme heat could impact their bottom line. Karen Kaifa is in Washington with a look at some of the numbers and ways for households to safely cut costs.
Extreme heat is becoming more frequent and more costly.
We would never think about planning for wildfire season or hurricane season just during those seasons.
Ashley Ward of the Duke University Heat Policy Innovation Hub says that these punishing heat waves make it more expensive to cool a home.
When temperatures overnight don't fall below 75 degrees, for example, it doesn't give the body or any living thing or our energy systems time to recover from that daytime exposure.
David Tinsley, senior economist for the Bank of America Institute, says their analysis found higher average temperatures boosting consumers' average monthly utility payments by 23% since 2019.
All the data is suggesting that these heat waves are hotter and are lasting longer. And so when that occurs, people have to turn up their aircon and leave it on longer, and that's adding to cost.
There's a burden on businesses, too. In a 2023 report, the U.S. Congress Joint Economic Committee cited data pointing to more than 2.5 billion hours of lost labor across certain sectors like agriculture, construction, and manufacturing.
These extremes of heat are really impactful. So it does have a somewhat depressing effect on the overall economy.
Extreme heat can also disrupt the airline industry. When air is hot and less dense, planes need less weight or more runway for takeoff. That can lead to bumped passengers or baggage or canceled flights. In Washington, I'm Karen Kaifa.
While this summer has been hot at times, it's actually not nearly as hot as what we've seen over the past few summers. For more on how summer 2024 compares to the past 2 years, we bring in First Alert Chief Meteorologist Brady Taylor.
Yeah, Jillian, what a difference a year makes. So the last 2 years, 2022 and 2023, we had over 60 100-degree days. On an average summer, it's about 24. And this year, we're way behind that pace. 3 is all the number of triple-digit days we've seen so far this summer compared to last year when we were talking about, at this time, already 17 100-degree days. And back in 2022, 36. Now, the big impact on all this, one is high pressure hasn't been built in as much this summer as we've had in the last couple of years. The other thing is the amount of rain. We're now over 30 inches of rain officially at the Waco Regional Airport so far this year. That's nearly double where we were last year. And at this point back in 2022, we hadn't even got up to 9 inches. So the drought, that coincides with the heat building in, and again, how it causes that high pressure to build in stronger and those heat waves to last longer. You can also see the big impacts the rain have had on our area lakes. So all of our area lakes are pretty close to right at 100% full. And I want to show you the change just in the last year. Lake Waco up over 9 feet from where we were at this point last year. Lake Whitney is not up as much, but it's such a huge lake that it didn't drop down percentage-wise as much as all of our area lakes, but still nearly 5 feet higher than this point last year. And you go into Bell County, that's where we see the dramatic changes. Lake Belton, nearly 16 feet higher than this point last year. Stillhouse Hollow over 17 feet above where we were last year. So yeah, the drought last year impacted the lakes, impacted the heat, and overall definitely a much better summer so far this year.
You may be tired of the sun beating down on us this time of the year, and maybe you've had a thought about what would happen if we tried to extinguish the sun. Well, up next on Weather Extra is this week's Moment of Science, and Dan Smith tries to do just that. We'll have more on what would happen right after this. Welcome back to Weather Extra. Although we've seen a brief end of the triple-digit heat the past few days, we're still most definitely in the dog days of summer, with the sun beating down across much of the country. What would happen if we tried to extinguish the sun with water? Well, Dan Smith tries just that in your Moment of Science.
I overheard somebody the other day on a hot afternoon like this. I wish we could just take a big bucket of water and put out the sun already. Obviously, that's a bad idea, but you know I love hypotheticals on this show, so what the heck, let's try it. The short answer is that we'd need over 6 billion times more water than Earth even has to approach the mass of the sun, and we can never make a big enough bucket to transport it, and all of that water would turn to steam and then plasma almost instantly. But let's say we ignored all that for the purpose of having a moment of science longer than a minute. The sun converts hydrogen to helium and essentially gives off and loses about 4 million tons of matter per second in the form of energy as a byproduct. Based off that, it'd be about 10 billion years before it goes out on its own, and currently we're about halfway through its life cycle. For comparison, if our sun were the mass of the Earth, it would go out in just 50,000 years, a blink of an eye on a cosmic scale. Burning something on Earth typically happens through chemical combustion, where you're rearranging bonds between atoms without changing the nuclei of the atoms themselves. Combustion needs 3 key ingredients: air, fuel, and heat. Throw water on a fire, it coats it and stifles its components. The sun, however, goes through the process of nuclear fusion, in this case, fusing together 2 hydrogen nuclei to form helium on a massive scale. That's because of the intense pressure that its own gravity exerts, pulling everything in. Now that's a lot of fuel and heat to overcome, so what about the air, the atmosphere? Well, good luck finding that in space. The sun already does perfectly fine without it. Here's the key to our question. Since water is 2/3 hydrogen, adding that big old bucket of it to the sun would be giving it fuel, making it twice as heavy and twice as hot as its core. Since the sun's energy output is its own mass to the 4th power, doubling its mass means it ends up 16 times brighter. Congratulations, you've managed to boil the Earth, and if there was life on Mars, don't worry about that, it's gone now. Somehow, I don't think these babies are gonna cut it. Look, maybe we should focus more on conserving water, the source of life on Earth, instead of trying to kill the other source of life on Earth. For this week's Moment of Science, I'm Dan Smith.
Straight ahead on Weather Extra is this week's episode of Degrees of Science. This week, Brady Taylor spoke with a researcher from the University of Texas who's finding ways for us to shift from using fossil fuels to cleaner energy. Learn more about the research being done when we come back.
Welcome into this week's Degrees of Science. This week we're talking about some amazing research being done to produce hydrogen from rocks. So today we're talking with Dr. Tody Larson from the University of Texas, a researcher in their geology department there. Dr. Larson, so first, before we get to the research you are doing, why is it important to try to produce hydrogen? Why is that so important?
Well, there's a lot of emphasis looking at sort of transitional fuels, transitional energy, kind of moving away from kind of fossil fuels and moving into some new directions. And I think a lot of people are familiar with kind of batteries and electric cars and electric vehicles. Well, the new frontier that we're investigating is actually using hydrogen. And if done correctly, it presents a carbon-free or a carbon-neutral way to fuel the next economy.
So currently, how do we produce most of the hydrogen that we have?
We make it from natural gas. That's the most likely way to do it. Natural gas has a lot of hydrogen within the molecule, or methane does. And so we use methane to produce hydrogen in an industrial process. And with that, we can store hydrogen for, whether it be for agricultural uses, energy uses, or as a feedstock for additional fuels.
But when it's made from natural gas, it's putting off CO2. Is that the big problem that we're running into with it?
Yes, that's correct.
Okay. So let's talk about y'all's project. So how exactly are you making or getting hydrogen out of iron-rich rocks?
Well, we're using a natural process, and so hydrogen's made from rocks naturally, and we do find accumulations of hydrogen all over the globe. And so that process is called serpentinization. And with serpentinization, you're using iron that's in the rocks and you're oxidizing it. And by doing that, you're reducing water to generate hydrogen. So the real process that we're tracing is trying to make hydrogen from water using these this natural chemistry that's happening already.
So is it certain rocks, or I mean, I'm guessing not all rocks are iron rich. Is there certain areas that you are looking for these rocks?
Yeah. And so any of the rocks or any of the minerals that have iron, and specifically iron 2, it's a special type of iron, or it's a very common type of iron, but it's reduced iron. So any rocks that are rich in iron 2, and so they fall under the category of rocks that we call ultramafic or mafic. And so think of lavas, think of basalts and things like that. Those are types of rocks that have enough iron in them to be considered in our process.
So how much hydrogen can these rocks produce? Is it a small amount per a big group, or can produce a lot of hydrogen?
No, it's a lot. It's a lot depending on how you add it up. There's an incredible amount of iron 2 that's in the Earth's crust that's relatively shallow and accessible using today's technologies. And so if you add up all the iron that's available and that we can utilize, you're talking hundreds of years of hydrogen that we could supply.
So what kind of natural catalyst are y'all able to use that get this process going?
Yeah, so one that's really common and that we're investigating is nickel. And nickel's found in a lot of these iron-rich rocks. The particular mineral that we're looking at is called olivine. And so any rocks that have olivine with elevated concentrations of nickel are part of what we're initially going to be looking at. And then we're looking at all sorts of sort of engineering aspects where we'd actually inject co-inject different types of catalysts that might help lower the temperatures that these reactions need to be at to generate hydrogen.
So you're doing this right now in a kind of a laboratory setting. I know y'all got a grant to kind of make this a little bigger. What's the next steps to make this where you can produce more or make it in a bigger scale?
Yeah, no, it's a great question. Yeah, so we were recently awarded a grant from one of the branches of the Department of Energy. It's called ARPA-E. And with that grant, it really is a benchtop experiment. And so we're trying to categorize all the iron-rich rocks that are common throughout North America and globally. And then we're going to run these experiments in our laboratory to try to estimate how much hydrogen we can produce. And then we're going to look at different catalyst strategies to try to increase the amount of hydrogen that we can produce. And so then the scale up to that obviously would be taking our lab experiments and then going to some field sites and trying to duplicate what we're doing in the lab in the field.
So, I mean, you seem to be moving along well in this. Say you looked at a 5 or a 10 year down the line kind of deal. What would be your ultimate goal with this pushing forward?
Yeah, I mean, it's a little more aggressive than that. There's already a lot of exploration that's happening looking for natural deposits of hydrogen globally. And there's a lot of activity in that field right now. With our activity, what we're really looking at is to find these areas that might be producing some hydrogen, but essentially trying to coax more hydrogen out of those rocks. And so I'd say in the sort of 2 to 3 year plan, the goal would be to take our technology and then employ it in the field.
You can find out more about this research project taking place at the University of Texas in Austin by scanning the QR code on your screen to watch on YouTube, or you can head over to our website at KWTX.com/degrees of science. Weather Extra will be right back. Welcome back to Weather Extra. Nearly 30 years after Twister stormed into theaters, a new generation of tornado chasers hit the big screen this past Friday. David Daniel has a look at the new movie called Twisters. Take a look.
Twisters was a natural for director Lee Isaac Chung, who grew up in rural Arkansas.
When you have brushes with extreme weather as a child, anything that feels larger than life and dangerous, I think those things leave a very big imprint.
We got PhDs from NASA, FEMA, and Kate. She's the smartest person I know.
Hey dudes, this is interesting. Who are they?
It's Tyler Owens, calls himself a tornado wrangler. If you feel it!
The stars say they were overwhelmed by their real-life counterparts.
They're like mad intelligent about the weather and science, but also like adrenaline seekers, and they all have like crazy dents in their cars from grapefruit-sized hail, and Are those fireworks?
Yes, ma'am.
It just felt like we were able to take the inspiration from the first movie and then really just hopefully, you know, take it up a notch.
Oh, she's perfect! She's gorgeous!
That sense of awe and wonder was something that I really wanted to preserve in this film.
CGI sequences are massive, but also they did a great job with the actors of like actually hitting us with wind and rain and ice rockets and stuff to make it feel like we are in the eye of a storm.
We went through the elements to make sure audiences felt that ride, and I think that was never a scary day, that was always a thrilling day.
You don't face your fears, you ride them.
In Hollywood, I'm David Daniel.
And before we go, Saturday marks a very special anniversary of the Apollo 11 moon landing. It was 55 years ago that Neil Armstrong walked on the surface of the moon, the first astronaut to ever do so. Armstrong's Apollo 11 space mission touched down on the moon July 20th, 1969. And just this past week, scientists announced their discovery of the first cave on the moon. It's right next to where the Apollo 11 landed. Some scientists speculate it could even provide some shelter from temperature extremes on a future mission. Well, that's all we have for you on this week's episode of Weather Extra. Looking ahead into the new week, we thankfully will continue to keep the triple-digit heat away, along with some nice rain chances too, which is definitely welcome this time of year. Have a great week, and we'll see you again next weekend for another half hour of nothing but weather and science.